This is problem number 5 from projecteuler.net, and the title of the problem is Smallest Multiple. 2520 is the smallest number that can be divided by each of the numbers from 1 to 10 without any remainder. What is the smallest positive number that is evenly divisible by all the numbers from 1 to 20? So this problem, you don't need coding at all to solve this problem. This is purely a mathematical problem that is trying to find something that we learned from primary school that is called the least common multiple. Right, the least common multiple is basically the smallest number that is a multiple of all of the numbers within a set of numbers. So we're trying to find here the smallest number that is a multiple of all the numbers from 1 to 20. That's pretty much it. We don't need code, we don't need complex algorithms, we just need pen and paper. So let's just create here our problem 5. And let's create here our file, problem number 5. Yes, so this is going to be a mathematical solution. Right, so we just need to find for all the numbers from 1 to 20, we need to find the prime factors of these numbers, and multiply the highest power of them, each prime factor found. We can do this one by one. 1 we're gonna ignore because it's just 1. 2, it's a prime, so the prime factor of 2 is just 2. Same thing for 3, the prime factor of 3, 3. For 4, the prime factor of 4 is just a 2 power 2. 5 is another prime number, so it's just 5. 6 is the prime factors of 6 is 2 multiply 3, right? 7, another prime number. 8 is 2 power 3, right? So this is the prime factors of 8. 9 again is 3 power 2. For 10 is 2 multiplied by 5, right? For 11 is another prime number. For 12 is 2 power 2 multiplied by 3. The prime numbers of 13 is just 13 because it's a prime number. The prime numbers or the prime factors of 14 is 2 multiplied by 7. The prime factor of 15 is 3 multiplied by 5. The prime factors of 16 is 2 power 4. The prime factors of 17 is just 17 because it's a prime number. 18 is 3 squared multiplied by 2, right? 19, again, another prime number. And the 20, it is 2 power 2 multiplied by 5. So what is our result? We need to get the highest power of each of the prime factors that we find here in this collection. Right, so let's go one by one. 2, the highest we find is 2 power 4. So 2 power 4. We multiply that by 3. The biggest one we find for 3 is 3 squared, right? So 3 squared. And all of the others, I think it's just like itself, right? So 5 happens just once. 7 happens just power 1 again, so it's just 7. Same thing for 11 just once, 13, 17, and 19. Actually, this already should be our answer. Let's just run this very quickly here. Again, we're not doing any code. We're just like finding the mathematical solution. So this is the solution. This doesn't seem very right because this one here is not correct. Okay. So this should be our answer. Let's copy it. Let's paste it here. And let's give it a try. This is the solution to the problem then. So as I said, like we didn't do any code to solve this problem. It's just like finding the prime factors and the least common multiple is the solution to this problem. If you really want to write a code to solve this problem, we can do it. We can write a code to find the prime factors of a collection of numbers and then multiply the highest power. And if you like it, please share, subscribe. Yeah, and I see you in the next problem. Peace.